Hey everyone, and welcome to the Open Office Hours coding for May 2nd, 2012. We will be covering the C++ 101 course and the C# 102 course here. So I'm here, my name is Nelson, and Gavin is here.
My name is Gavin.
Awesome. So let's go ahead and start answering questions. So go ahead and post your questions in the questions webinar. We already have a few that I guess we're going to go over now. How should we be making files? With StreamWriter or with file.create? Well,
before you actually dig into it, that I'm guessing is a C# question. If you can make it clear whether it's C# or C++ you're referring to.
Yeah, he's going to be referring to the C# stuff, where during the console or during the prompt for the homework, I asked that people create a text file. And when you want to write things to a file, you're going to be using a StreamWriter, generally. Oh great, I don't have ReSharper installed. This is typically what you will be using to write to a file. So if you actually have information that you want to write into a file, then you're going to be using a StreamWriter to create a file. However, if all you need to do is to create a file, file.create is a nice alternative as well. Now you do get, with file.create, you do get a little file stream thing that I didn't really talk about in the last class. So if you were to do file.create to just create a file, I would do file.create.dispose so that the stream gets closed. I know I didn't go over that, but that's an important detail that I kind of forgot about just because I haven't used the file.create method particularly much, because the file stream that's passed back is not going to be a the file stream that's passed back isn't going to have the same functionality as a StreamWriter. So it's typically better to use a StreamWriter than a file stream object. Now, of course, you can wrap a StreamWriter around a file stream if you wanted to, but basically this is going to be generally what you want to do if you want to write stuff to a file.
Almost always you'll be wanting to create it. You'll be wanting to put some information into the file.
Right.
When you create it for the first time.
And the file stream object is great for writing binary data, but the StreamWriter is what's going to handle encoding for you behind the scenes. So to mimic this behavior with file.create, we would have to do this. And hopefully people will see why it's a bit uglier. So to mimic the behavior between the two, that's what you'd have to do. It's not as good. I do want to point out, though, that there are some nice little properties in the overloads to the file.create method, like buffer size. You have file options, which is just a bunch of random stuff that I'm not going to get into. File security. So there are some additional things that you get, but none of them are going to be particularly useful for the purposes that we have at the moment. How can I make a file in a folder that has the same folder that the program is in? So I don't have to create... How do I make a file in a folder that is in the same folder? You can use a relative path. So for example, I can say directory.create directory blah, or I can say if not directory exists blah, then open up a new StreamWriter to ble text.txt after we create the directory. So if I were to run this actually I have to do a control because I'm using this stupid thing and stuff. So now if I run this program and locate my my executable, you'll notice that a file was indeed created inside of the folder that I created.
And if you hadn't have added that blend, so it was just test.txt, that would have been created in the same root folder as the executable, in this case debug.
So this folder indeed got created, and we indeed got a text.txt file in it, and if we open that, we'll notice that it has the output that we specified on line 20.
And someone asked, if the streamwriter block is empty, would the file just be empty?
Yes, that would create an empty file. The default behavior, I can't remember if the default behavior, okay, the default behavior is going to be it's not going to append. So this code will essentially either create test.txt or erase the contents of test.txt.
Yeah, it's always definitely worth, when you get into filing out, double checking belt and braces about file existence and how you're handling what to do if a file already exists. Because otherwise you can find things like that happening where you've just destroyed anything that was in there.
In the homework, what are the new game command, save game command, and load game commands to be used for?
Can I just say, if you do all the homework, all the ones that are actually related to that in a block in a minute, if you skip down the next question, it's still related to the filing out stuff.
You have a var directory info equals new directory info C. But how do you check for a folder that is in the folder your program is in, like you said we should do, not direct access? How do you check for a folder that is in the folder? Like this. Or like this. Yeah, you probably caught that. This would also properly check for a relative path based off not where your project is located. I really want to point this out. So I'm going to navigate into where my project is located, and then I'm going to go into the project. Now you'll notice there is no ble folder here. The ble folder is going to be next to the executable. And the executable is going to be in the bin debug folder. So as a result, you see the executable right here, and there's the ble folder.
And in fact, if you was to, I don't know if you can do it with just the way you're set up, but if you were to drag the exe onto your desktop, it would be relative from your desktop.
So now it's on my desktop in a different folder. If I run this program, you'll notice a ble folder appears with the test.txt file in it, because it's going to be relative to wherever this executable is. Okay, any chance I can zoom in again? Or a bit, sure. Why is it called file stream when all we see is file? Are you asking why a file.create returns a file stream? I mean, I guess what you might be being confused about is the difference between invoking a static method and instantiating a class. So for example, if I create a new file info class, I'm instantiating an object. And the reason when I'm instantiating this object, what I get back is a file info. However, if I do file stream fs equals file.create, notice that I don't have the new keyword here. I'm not instantiating anything. All I'm doing is invoking a method on the file static class, and this method is free to return whatever he sees fit. And in this implementation, he returns a file stream object. So this is not instantiation. This is just simply invoking a static method. With file.writeAllText, it doesn't allow dispose as something needed similar to it. It should be good as is. File.writeAllText is not going to return anything. As you notice, the static method is
void return type.
Is void return type, and that means it doesn't return anything. It will internally instantiate a stream, set it to a file stream, write the text, and then close the file stream internally. But we don't get a reference to its file stream when we do write_all_text. I'm finding the homework hard to complete without just copying Nelson's code. I've been trying to do it from my understanding and only referring to a need to. However, I feel it will look very, very similar. I said this multiple times in the class. I really wanted to stress this point. But I don't care if you copy everything I wrote verbatim. And that's why, although it was, usually we do not do a discussion, an example of what the homework should look like in class, but because it's such a new concept to so many people, and because it's such an important concept, and because it's going to be, those concepts that you're going through in the homework is what this entire 102 class is going to be focused around. If you had to copy what I did line by line, then that's fine. And remember, though, there are so many ways to represent architecture. Just like with a building, I mean, you create the constraints of your architecture, and when you create those constraints, then the amount of ways that you can express that same architecture start to diminish. So there aren't going to be very many valid ways to express the logic that I'm looking for using the architecture that I specified without using very similar looking code.
Could you put together a very, like an entirely generically named example of just the whole deal with the sort of command and state relationship? Because it is a bit blurry from the homework definition you gave due to commands and states, and it's just like you say, it is such a key thing that people get their head around.
First of all, what's the point in copying line by line? I'm here. I heard you, but I would want to address what Segfault said. What's the point in copying things line by line? Nobody's going to understand it that way. That's the first way to understand it. Seeing a working program that you copied down is how it works for the most part for such new concepts like this. I mean, even with that's generally what XNA 101 did.
Well, absolutely. This same project in XNA 101 was pre any discussion of anything.
So actually writing it down is it's the first step, and there will be times where you will have to come up with things on your own. I'm not going to display everything in the homework on every class because I want people...
The key thing is that this... the first time you do it, you literally just write it out, and you end up... And the more you do it, you start to see the patterns that are there. You start to go, oh, I see, if I'm doing this, then I'm going to need an interface, and then I'm going to need this here and this here. Because the pattern comes up over and over again. But a lot of people have been confused. But
I hope people who were confused, they did copy it down line by line, and then I hope that was their first step. And it's still fine if they still are confused after that. But even having that experience of doing that, of typing out the code and watching the program compile and run, will create pathways, neural pathways in their brain.
Said, debug mode and stepping through definitely helps. Yeah, copy the code in and then put a breakpoint on the first line of main and see what the code does in what order. Follow it through. and see where it, and get the relationship between the parts in your head. Ooh, more questions.
I'm finding the homework. Is it okay if we put our files in a folder that we make and not just the one with the exe for the C# homework? I would want the files to be relative, but they can be in a folder that you create. You can create a folder relative to your executable as much as you want, but just make sure that it's a relative path, not a absolute path. In C++, is it acceptable behavior to write helper functions in CPP files that aren't defined in the header so that they won't be publicly available? Yes. Just make sure that you wrap it in an anonymous namespace so that you don't get linker conflicts if a similarly named helper function exists in other CPP files. For the C# homework, why are we supposed to render nothing in the new game state and just use the new game state to show text line? We did in help command and not the render method in game state. It's because it's a placeholder. The code isn't supposed to be completed. You weren't supposed to build a text RPG in week 1.
I think, yeah, but see, this is why I said, can you please do an example? Because people are fundamentally misunderstanding what the commands do, what the states do.
The goal of the homework was to create a state system that allowed the transition between multiple states and having each state support the ability to represent commands. Okay, and I'll go more into that later.
Yeah, Segfault nailed it in BuzzNet. I'm unclear from the spec given as to exactly what should be doing what.
Homework. For the state command, is it required to have both the new game and the new game command when you have the save option being written to a file? Could you please, I'm not sure about the question.
Basically, everyone is saying, can you please explain what they've got to do for the homework? Fundamentally, that is the route that everyone's saying in class, in BuzzNet, and on the forums. No, it's not clear what people should be doing.
Okay, well, the idea of the homework was...
Bring up the thread, and you'll see that, and I can point out the part of the problem at least. Yeah, the help command, for instance, does stuff that in the rest of them it's done by the render of the...
That's because the help command doesn't have any commands. The help command prints out text and then returns back to whatever state invoked it. The other states represent a transition of the program. For example, in the load file state, that's a state because it has to accept additional commands in order to perform its operation. The new game state is more or less just a placeholder. Or it is just a placeholder. The save file state, again, is that you can pass in multiple commands into a state. That's what makes it a state. The individual commands are just bits of functionality that are executed and then immediately returned. It looks like there is a bit of... I might have mistyped out these two things.
Yeah, I mean... I'm slightly confused from that description there. What I'm trying to say is it's hard for you to see where the problem is because you know what you intended to write. Read what you wrote rather than what you know you intended to write, if you see what I mean.
Right. It was more or less just an exercise on state and command transitions. And the idea is that this is so malleable. I mean, I should have specified, and this is a very difficult thing when assigning homework, when you want to express a concept, when you want people to express a certain bit of behavior using a new concept. I'm not that worried about the actual physical implementation, and I think I should have probably mentioned it in the prompt itself. But I've been finding that there's a fine line between having a specific requirement and having a specific express this concept in your code. For example, we do this quite frequently. What?
I was just going to say, but like with Wolf Knightley's questioning the question, why does help not have a help state when new game has a new game state? Or it should be, why does the state not have a command? There seems to be some overlap.
But there is a good reason for it. The reasoning is help command, because the help command does not accept any additional input, it just executes its code and returns. There's no reason for it to have a state. The save game state, the load state, and even the new game state, and the main menu state, what characterizes these as states is because they are screens of your application that can accept additional input. A help command is simply prints out text and returns. It's a very simple, straightforward bit of logic. It doesn't require any additional input. Because a save command, well, as far as the save command, the way I was envisioning it was you typed in save, you went to the save screen, and then you were presented a list of file names, and you could choose one, or overwrite it, or type in your own file name. Okay, well, I agree it does need to be much clearer, but again, it all boils down to the fine line between specific, repeatable instructions and specification and an overall concept that I really wanted to express.
Can you think of another example scenario to demonstrate the whole state and command thing that isn't literally giving them the home,
Okay, but I want to point out, it's not about the states. It really isn't. It's about the transition between them. It's about the code that goes in them. It's about wiring them up with infrastructure. Most of these states don't do anything really that important.
But that's why people can't understand what they're there for. Because they don't do anything.
Right, and that's the way I named these particular things the way they are, because I was hoping people would make a connect between what they're naming the specific state and commands are with what you might expect out of the final game.
Yeah, but for example, I imagine a lot of people are thinking, well, what should I put in a command and what should I put in a state for a command, and when should a command also be a state, and when should a command just be a command, and when should a state... I mean, really, it's not clear. So please clarify.
If
you can't just keep saying, I know it's not clear. I know it. Please.
I didn't say I know it wasn't clear. I mean, I apologize for it not being clear. I mean, that obviously, like I said, it's a fine line between specificness and more generalness.
Yes, we're not getting at you for it not being clear. We just want you to show us how to do it, or what to do.
Right, and the idea was to make a basic system with two abstractions. You have your states, and you have your commands. And the idea was to use these two abstractions to accomplish some sort of goal. And that goal... You what?
I was going to say, so what would the flow be through the program then?
Well, for example, without having the actual infrastructure code written, just having the interface definitions and a few classes that implement those interfaces...
Or even just one class that implements each one for now.
Sure.
Just to keep it as simple as possible.
Actually, I need two commands.
Well, that's a good other one to have.
Okay, and then if I were to, now that I have these guys, and I'll step through them in a second, I'll write an actual working program. So I'll have an iState current state equals new main menu state, while true, current state.render, followed by var cmd equals current state.getCommand cmd.execute. And now when I run this program, we pretend this is presenting a main menu. And if I type in garbage, I get invalid commands. If I type in help, I get help text. But notice that when I type in help, I get the help text command, but I stay on the same state. In fact, it might be clear if I did a console.clear right here, where I run this, and I say the main menu gets presented. Now I type in an invalid command, and, well,
I think you wanted to do a clear at the top of that, man.
I wanted to do it after the render, but before the command. So now when I type in an invalid command, I get an invalid command message up here. This invalid command message is the command executing. However, the command itself does not change the state of the program, and as a result, we remain on the main menu state, which means we get represented to us a main menu. Now if we type in help, the command that gets executed is the help command. We get our help text, but then we're still on the main menu state. For example, what if we had a really simple class called room that just had a public string name? That's all it has. Now I can create another state. Let's go ahead and I want to create a room state. The room state's constructor takes in a room. This is the room that this state represents. When we render it, we say console.writeLine, we are in room blah. And when we get command, at this point things get more interesting. I'm just going to return, I'm going to have to create another command to switch between the states. And that's actually, switching between the states gets a little bit more complicated. But the idea is that this would, handle actions that can be handled inside of a room, such as look, or take, or move. And we can worry about the state transitioning later as we get further along with this example. So now if I go ahead and run this code, you'll see we instantiate a new main menu state. We set that to our current state. We ask our current state to render itself, which it does. Then we ask our current state to get a new command, which will ask the console for text. If we type in help, it'll make a decision based off this input. In this case, this is help, so we execute line 53, which means our command is now an instantiated help command, which then gets executed right here. Because no state transition happened, we're still in the main menu. So that's why we can now support two distinct commands.
Sorry, reading.
But if we wanted to do a state change, we would call change state command. Yes. However, that becomes a little bit more complicated. I can show that's where the infrastructure comes in. See, just like this, if we didn't have any state transitions, our code could remain this simple. Actually, it could even remain this simple. I'm going to go ahead and in program, I'm going to make a public static iState current state property. And then I'm going to set current state to new main menu state, and then I'm going to just use this property. Now the reason we're setting this to a public static iState here is so that we can write code that switches the current state, even though this isn't how I did it in the original example because I had a little bit of more helper code to do it for me. So now I can go ahead and create a change state command. Come on, Visual Studio. Don't be like that. The change state command takes in a I state to switch to, and it sets it to a private variable. When we execute it, all we do is we say program.currentState equals new state. So that's how we execute this code. So now instead of main menu state, let's say things are a little bit more complex. If I said var parts, I'm going to drop implicit typing for now. Input.split on space, if parts.length is 2, and parts at 1, first index is move. Then I'm going to return a new change state command. Now, when I return a new change state command, I need to provide it a new state to actually switch to. So I'm going to pass in a new room state. Now, the room state needs a room so it knows what room it's in. This I'm going to basically just going to cheat. I'm going to instantiate a new room, and I'm going to set its name to whatever I typed into the move. So I'm going to say var room equals new room, and I can say room.name equals parts at the second index. Then I'm going to copy and paste this code into our room state get commands method.
Copy and paste or cut and paste?
I meant to copy and paste it. Did I copy and paste it?
I'm not sure. That's why I asked.
No, I did. Okay. Okay, so now, or actually, I'm going to, sorry for keep on changing this. I'm just going to change this to if input equals start, then, if input equals start, then we'll just say room.name equals starting room. Okay, so it does have a little bit more complexity here, but I'm going to go ahead and collapse all my definitions because I really do have some limited screen space, which is not helping in the slightest.
I think really it would be better to zoom out one level, and people will just have to look a bit closer. It's far better to be able to get the shape of you know what I mean?
Right.
The structure of the program visible when rather than jumping around so much.
So now when I run the program, I say pretend this is a main menu, and now I can say help, which executes the help command, or I can say start, which gets me into a room. And I forgot to actually access the name property on that one. Now we can move to different rooms. So what I wanted this example to demonstrate is the fundamental difference between a state and a command.
So expand out the interfaces themselves and just go through this, the most basic level of what is going on when you know, say I was to say, okay, right, I need my program to do something. I can't think of off the top of my head.
Well, let's say we wanted to present a load screen to a user.
Yeah.
Well,
go through the thought processes one by one, slowly, with highlighting of brain activity.
Right. Well, if we wanted to present a load screen to a user, we know that we need a user interface for the load screen, and we know that the load screen is going to accept a variety of input and perform different operations depending on what happened. So right here we have this interface iState, which represents a screen of UI that we can use to render the load menu, and then to ask this screen if a command got typed into the console window that it knows how to execute. So we would start off, we know that we need a load screen state because we know we have a user interface for the load screen. The I command will be used for representing individual blocks of executable code. And if we think about it, although our load screen will present the user interface, there are two valid commands. There's a back command that will go back to our main menu state, and then there's going to be a load space and then file name command. So we're going to have two commands. Now we already have one of those commands coded for us. We already have the change state command, which we can use as a very general basis to move between states.
Do you want to just open that up again?
And all this does is it takes in a new state and then it sets the program's current state to the new state when it executes. So very straightforward, blah, blah, blah code.
I actually think that's probably, certainly for people new to this, that's a more understandable way to see what's going on, probably than what you did initially the other day. I don't know what anyone else thinks. It just looks, you can see exactly what's going on a bit clearer. But actually, I mean, again, this is an interesting point. It achieves the same result in about the same amount of code as the other way.
Right, I'm just using...
Or very nearly. But it's just a question of finding... Again, this is the whole thing. This comes back to the typing it out thing. As you type it out, you start to get a feel for what ways you like to use the syntax available to you, in the same way as everyone speaks in a different fashion. What is the difference? What between doing this and doing what was shown in the first video?
The difference was that instead of using a static field or a static property, it was changing it was invoking a method on an object. But it did the same thing. Just it invoked a method on an object instead of using a static property.
But sorry, I kind of interrupted you mid-flow there to explain that bit.
Well, there have been a flood of questions. I don't know. I think I should...
It's tricky because there just have been such a flood of questions on this particular one, which I suppose is inevitable. It's the first big sort of chunk of design stuff that we've come to.
And in this example, when I initially was coding the RPG game, I found this to be a very appropriate way to organize the code, and I thought it would be an interesting way to introduce people to this sort of abstraction. But what you'll get after writing code in this fashion or using any sort of design is much smaller blocks of code in easier to find places. And that's ultimately the goal of design and object-oriented programming. So that's why this example is particularly complex, but on the same token, I mean, the whole idea of object-oriented programming is managing complexity. And if we don't have any complexity to manage, then we have no true example. This was, again, the number one problem that I had when learning object-oriented design, which is something you never stop learning, by the way, just like programming in general. But all the examples that I saw were so contrived and so obnoxious, and they didn't really provide a good, clean way that that showed using these language features to accomplish a goal. So that's the goal. And as far as the questions, I think I'm just going to run through what I was originally talking about. I'm going to run through the creation of a load state and a load command and talk about the difference between both of them. And then I'll go through the questions panel.
Yeah, that'd be cool.
Where's program.currentState defined? I will answer that. That's defined here on line 114 in the program class.
Keep in mind that at the moment we have still got all the classes in the one CS file.
Yes. Okay, so working on a load file functionality, we've identified, given that in this design, in this particular architecture, we have two abstractions available to us, two ways that we can express a class and plug it into our code. We have states and commands. And we've identified that we need a state because we need to present a user interface to a user that can be re-rendered. And we need at least one command because we need to actually perform an action underneath that state. So what I'm going to do is I'm going to go ahead and create the load file state. Now it's going to implement iState. The render method is going to present a list of files. So let's go ahead and just do this. I'm just going to go ahead and say for var I equals 0, I smaller than 5, I plus plus, console, right line, x.
This is going to be a file.
And then console, right line, so here's our nice little state. Now to implement our get command, all we have to do, slowed. All we have to do is I'm not going to use readline. I'm going to use read key. So I'm going to say var key equals console.read key dot key character. Then I'm going to say if key is greater than 1, greater than or equal to 1, and key is smaller or equal to 5, then I'm going to go ahead and say return, and I know I don't have this class yet. Say convert to key. Otherwise, if key is x, return a new change state command, and I'm going to fill that in with something in a second here. And then finally, if key is nothing else, return a new invalid command. The key thing is we're just asking the console for a key. So when
I was wondering, what does it return for, say, enter as a key char?
I have no idea. Probably a new line.
Okay.
So it just returns a key press. So we'll only be allowed to press one key, and then we can type in 1 through 5, which is our we have 5 save slots, or we can type in X, which will return us back to the main menu. Okay. Now, here's an interesting thing. Before I implement the load game command, there is an interesting problem I have to solve. And here's how I would go about solving that problem. We need to change the state, but we could instantiate a new main menu state. That would work just fine. But I kind of don't want to do that. I want to demonstrate how you would be able to go back to an existing state that might have been running. And doing so is really easy, because all we have to do is in the constructor of our load file state, we can say last state. So when we construct our load file state, we pass in the last state that was active. So then, inside of our change state command, when we hit X, we can simply say change state to last state. So this will bring us back to the main menu state. Now to implement the load game command, I'm just going to use this really just as a placeholder again. Because it's less about the functionality inside of the load game command as it is about the architecture that we're expressing. So the constructor of the load game command is going to take in an integer. As you see right here, I convert the key into an integer. And the reason I'm doing that is so we can choose which slot we want. And you would probably want a file name or something. It's, whatever. And when we execute the game command, we can just say loading game from slot. So now, I'm going to go over the code again once more line by line, but I do need to add a little bit more code inside of main menu state. I need to say if the input equals load, then return a new change state command, passing in a new load file state, passing in itself. So let me break this down. We want to return an instantiated change state command. That's going to be a command class that's going to allow us to switch our state. Then we're passing into it an instantiated load file state. So we're instantiating a new load file state, and then we're passing in this into the constructor of the load file state. Yeah, literally this, because this is going to be the main menu state. So that's how the load file state is going to be made aware of the state that activated it, so it can go back to it. So now when I hit F5, I can say load. And I can sit here and type in invalid commands all I want. But if I type in like 3, loading from 51, oh great. You get the point. When I type in like, I'm gonna
yes, just subtract 48 from each of them.
Yeah. And when I hit X, I jump back into the main menu. When I type in load and hit enter, I jump into this load game state. When I hit the key 1 or 3, I get loading game from slot 51. The reason I'm getting this is because I forgot that convert. Let me fix that real fast. I forgot that convert 2 and 32 is actually kind of dumb when regards to characters.
Yeah, that's the ASCII code if you think about it, Chris, for 52.
Yeah, and then doing this, subtracting the character constant 0 will get me the actual number that it represents. So now when I type in load and hit 1, it says loading game from slot 1, 2, loading game from slot 2, 3, 4, 5, and then up to an invalid command. And then when I hit X, I jump back into the main menu. So I can type in help. Now help, when I type in help, I get the help command, because all help does is it renders text and it goes away. That's it. When I type in load, however, we get an entirely new state because a new user interface is presented to us. So I can type in 2, 3, 4, 5, and then 6 is invalid command, or I can type in X. I can also type in start, which will start the game, essentially, into my very basic game loop that I have represented by my room state. Because my room state, which is down here, when it renders, it says, we are in room blah. When we get the command for a room, all we support right now is moving. So this is saying, split the user input into an array by spaces. Make sure that there's 2 parts, and that the first part is move. If that's true, instantiate a new room object, which, if you recall, is a simple class with one single automatic property on it called name. We set the name of the room to where we want it to move to, and then we return a new change state command, passing in a new room state, passing in the room that we just instantiated.
And someone did ask why you would need the last state functionality if the only place to access load file command is from main menu.
Why would you need the what?
Why do you need the last state functionality if the only place to access load file command is from main menu? The thing is, it might not be the only place to access that from, for a start.
I mean, that's the whole point of using interfaces, because I could pass it to any state as the last state. Yeah, this is just a demo of a concept, and the concept is transitioning between different classes that implement particular interfaces given different input from the user.
You could break the whiteboard out and maybe give an example of logic, perhaps after a break. How long have we been going for?
About 50 minutes, so yeah. And that's why we...
If you,
Wow.
okay.
Hello?
Yeah.
But Musar just said, I understand that fully or in general. With the homework, though, it seems like you might want to stick to the script a little. And again, I should have... definitely the prompt should have been written better, and I apologize. But what I really wanted to express, which I didn't because I failed at writing the prompt, is that this is not an exercise into getting a program doing a specific awesome thing. Because the specific awesome things that the program is going to be doing is what we're going to be writing over the next few weeks. This was an exercise in writing multiple classes and encompassing functionality into particular classes so that you have proper organization within your code base. And that you have useful abstractions that you can reuse for a variety of situations.
I was just thinking, actually, the key things to sort of get your head around in this is not so much what is in those two interfaces, as much as how to decide what to put in an interface.
Or which one to use and how to break it out.
Yeah. The actual syntactic way of, defining an interface and whether you add accessibility modifiers and whether you add this, that, and the other is kind of secondary at this point to, again, it just keeps coming back to the same sets of words about it being a contract for tying down exactly what does what within your code.
Right, and as far as the specific instructions in the homework were just not written as well as they could have been, which is a bit of an understatement. But the point was to give people, like what Musar said, I like the word just script, just an example of what to do, and we will be using all of this stuff will be of use to the actual end product of the game. We will have a main menu state. We will have a load file state, a save file state. We will have a new game state. We will have a switch state command and a help command. But
the new game state is kind of, it's slightly conceptually confusing for now because
it doesn't lead anywhere.
Well, because it doesn't need it. But is that actually the game, or is it a new?
I was thinking.
I think
that's where you put
the
in
name. The naming's a bit. It makes it probably a bit confusing.
Yeah, I was thinking of that's where you would type in your name or something, your character's name.
More like a profile. One of those profile things you have to do. But But yeah, that's the thing. It's kind of like, what does the new game state do? Yeah. Is that more just a game state, like the XNA's game class?
It was gonna. I envisioned it to be something to the effect of typing in the character's name and then starting the game from there. You would go from a new game state into a room state, for example. If that makes sense. That would be the state transition.
So yeah, you see, I would call that a game initialization state, if anything. New game state, I think it's just because of the word, it sounds too much like new anything else. I don't know. That's possibly why it's slightly confusing. Segwit, on the other hand, thinks it's named correctly. But then he's waiting to get on break, so he's obviously run out of tea.
But yeah, and again, just like with all architecture, there's many ways to tackle a particular problem. There are an infinite amount of ways. Some, or a lot of them, will be arguably better or worse than other ones, depending on what you are building and what constraints you have within them. But the overarching idea of good design is knowing where code goes. Is knowing identifying abstractions, creating building blocks, and then building your program out of that. And this is one way to do it. This is one implementation that is good design for solving this particular problem.
And we've wrapped around, just before we have a break, we've kind of wrapped around to what Chris asked at the very beginning about my code being almost exactly identical to yours. But this is fundamental. I mean, this is from right out of the Gang of Four book. This is a named way of doing things.
Yeah.
It's
It's a specific design
probably
pattern.
talk more about it.
It's
Yeah.
two design patterns. It's the state design pattern, the command design pattern combined.
Yeah, it's what NATO said. Don't reinvent the wheel. And to a certain extent, there is. I mean, it's one of those things where if you think you can see a better way of doing it, then definitely try it, because you might revolutionize the way programming takes place. That said, various other people have had a crack at it in the past.
Yeah, and the idea of this, what makes this so applicable to this problem is the problem we are trying to solve, fundamentally, is allowing transitions between different screens on a text window and allowing the user to input text that produces a specific result. And that's essentially, those two sentences sum up what a state is and what a command is. A state is a screen that is rendered to the console window. A command is, well, a bit of executable code that alters the program's state in some way. But I'm going to go outside. Pausing video. I'm going to go ahead and resume.
What, before you do, what I was going to ask.
I'm going to go ahead and resume. Okay. So, we did have a question from Wolf, but I did really want to get through this sort of example. And are there any immediate feelings about this example? Any immediate questions or concerns? Okay, we'll get to the other questions then in a bit. So I'm going to go ahead and unmute Wolf. Okay, Wolf is unmuted.
Hello?
Hey!
Hey. Just put me on the spot, why don't you? No, I'm kidding. Okay, if you answered this, I didn't get it. But as far as where I'm confused on the whole new game thing is, in the main menu state, we have get command. And in get command, we have, we can type in load, and for, the command load, we have, and this is, I don't know, I don't mean, I'm not referring to what you did today, but what we, which I know it's very similar, but I'm referring to what we did in class last week. Anyway, we have load, and that returns a switch state command. We have save, we can enter save, and that's another switch state command. And then we have help, which returns a help command. And so if we're doing a new game command, I mean, if we're entering new game, then should we have that return a switch state command and a new game command, or one or the other?
Okay, I see where you're going. You would enter a change state command. The on the prompt, having this bit right here was actually a mistake, and I'm going to go ahead and edit it out right now.
So we're not supposed to have a new game command?
We will potentially have a new game command depending on how people go about doing things. However, that command will be executed from the new game state. Probably not, though. Probably the new game state is going to allow the user to enter their username that they want to play the game on, and then it's going to immediately switch into a room state. So having a new game command, that was a mistake to put it in the commands list, because it's not a command as much as it is a state.
Okay, you have new game command will be dead. Let's see, wait, that's random.
New game state will be a dead end for now.
Yeah.
And so presumably that will occur when from the load file
Yeah.
or from a specific new game.
So that will be in the render,
Yes.
like
And then
the line.
the get command would just probably be just a console.read key or something similar.
I mean, like this is a game. That's you want that in the render, not like we did help, because help we did it in the execution.
Right.
But
And the reason the reason this will be in a render in a state is because the new game will be asking the user for some information before it transitions into the real game state. And during, like for example, I can go ahead and pull up a bit of the logic that I have written for the game already, and I can show how that sort of transitions. In the project that I have right now, I do not have a new game state because I do not ask the user for their username, so keep that in mind. But hopefully this should clear things up for people.
yeah, that's a lot clearer, because from following the directions I had in my new game command, I had in execute, I had console write line. This is a game, but then I was,
I think the help command's is an edge case as well, and it's because I got sort of hung up on that in terms of understanding what was doing what from the other day. I mean, the help command is something of an anomaly. It doesn't work the same way as the rest of that does.
Yeah. I mean, it seems like the help command could be a help state, couldn't it?
If it allowed the user to enter information, then
But here's the thing: I don't. Sorry.
it's commands.
I mean, it's the command is the thing that. Yeah, it's hard to.
Oh, I get it, because help is. I was thinking like help was like directions. Help would be is a command that like help in this room, help in that room. Like it's anywhere during playing the game. So you don't want to. You would want to be in a game playing state and ask for help. You wouldn't want to go to another help state.
Yeah.
Yeah.
That you wouldn't. The help state would be specific to a particular screen. It's not going to be, or a particular state. Would it be easier to make all these commands as methods? And that's a question I did want to talk about. Where the thing is, these commands are essentially where you put the executable logic of your game in. That's the point of these commands. The point of delineating commands into their own objects is entirely for the purposes of breaking your logic out into their own discrete classes, and also for being able to reuse different commands in different situations. The screens or the states do have logic in them, but they're mostly a command processor. Like, for example, here's my room screen, or room state, and it is essentially a command processor. That's the majority of the code in here is parsing. Now, somebody said, well, what if I put my game logic inside of the screens themselves? Well, if you did that, you would end up with screens that are thousands and thousands of lines long. That's not what we want. The whole point of having the I command is all about forcing us to place our executable logic into their own classes so that our screens can do what they're good for, and that is printing out the user interface and then parsing the intent of the user. So if I were to run this program, so we're in a basic room, and there's a dog apparently, and we can go ahead and we can pick up the dog, or is it not pick up? What is it?
It's probably pick up spelt correctly.
So we pick up a dog. So what I just did was I executed a command. I executed a bit of logic. Now if I look at my inventory, you'll notice I have a dog. And I can't remember what... I really need a help command on each one of my states. What's in my inventory screen again? What can we do? Oh, we can just type in back. So now we can go back, and now we're in the room again. And now we can drop the dog. And now the room has a dog in it. Now we can move north. Or move south.
Your room never didn't have a dog in it, by the way, still.
You what?
You picked up the dog and got one from a different universe.
Right, that's because I didn't actually spend the time it would take to write the code that would make that text go away. Basically, this is the way I set up the rooms. I instantiate a level, I instantiate 2 basic rooms, I add an item to the first room, I connect them, then I add them to the level, then I instantiate the engine, I create a new start command, and I tell it to play.
You just didn't get around to the room1.remove item.
But yeah, there's going to be a little bit more functionality of this, but still. Currently, this isn't being loaded from a text file, but the point is because everything is separated out into their own objects, loading from a text file would simply be writing a tiny little, really, really simple text parser that executed this code for us, given a particular file. But anyway, so the point of the whole command code is to break apart our executable logic into these commands. That's all what the commands are about. So the idea is that at the end of the game, at the end of development, we'll have a variety of different commands that we can reuse on no matter what screen we're at, and we can easily find them. And most importantly, we can easily know about the commands by looking at a few different things. A few different places where your eyes should go when looking at a class are the top of the class and the constructor. So, for example, if I look at my move command, the top of the class, we have an engine, a direction, and a room, and our constructor has an engine, direction, and a room. I can execute this command from any point within my program, period, which makes it a very nice, reusable class that can encapsulate this logic and whichever additional logic I might put in, because this is the place where I would put in more complicated logic. Like, let's say, right here, I would say, if the room is the end room, then win the game. Or if the room is a huge trap, then kill the player, or something like that. Or I would place that into a particular room itself. And that's where that logic would go. These commands are the glue and the executable logic of your program.
And it either already owns or takes in everything it needs to deal with via the constructor.
You what?
Just talking about the separation.
Yeah, it takes in...
yeah, everything it needs, it gets at the one point.
Yep, which is great for it's... Looking at a constructor, you should know the general sense of what the class does. And this is why I avoid statics so much. I avoid statics so much because you can use a static from anywhere, but if you are not using static, then you must accept them as parameters, constructor arguments, or constructor parameters. Wow. You must accept them as parameters into the constructor, which gives you a nice language.
One thing that occurred to me that I just wanted to point out, which is the fact that obviously interfaces you can't have a constructor,
right?
But which means that two concrete classes that both implement the same interface could have completely different looking constructors.
Yep.
And I found it was one of those things that suddenly occurred to me that, oh, hang on a minute, there is no restriction on, the constructors don't have to match up in terms of what they take in.
Yep, because they fundamentally...
Or indeed what they return.
Yeah, because fundamentally different implementations of the same interface can perform completely different logic And in fact, that's desirable.
Because I think an interface, it's not so much a blueprint. It's better to think of it as a jigsaw piece, because it restricts what it needs to restrict, or it kind of does the opposite. It gives you a specific chunk of functionality. If he wanted to, there's no particularly good reason why he should, but he could quite easily create a new class now that implements all of those abstract, all of the interfaces, and fulfills them. He would just have to make sure that it fulfilled what each of them demanded of it.
Right.
They're almost like black boxes of functionality that you can string together.
Yep. And the whole point of this exercise is to get the first people's first taste of breaking code apart.
Well, I've got a good basic example you could throw up. One last one, which would be.
Before we get too far away, did I answer your question, Wolf?
Yes, I forgot about that.
Oh yeah, you did.
Oh, sorry. Okay. So what were you saying, Kev?
I want you to make me a cake machine.
A cake machine?
Yep.
What does it do?
It takes in. It has to take in sugar, flour, and butter. That's the minimum requirements for a cake. It can also take in currants and nuts, let's say, for different types of cakes.
Okay, so something like class cake machine. Then we could have an interface I cake material.
And focus on Nelson commentary on what he's thinking. If he will continue to give one.
Well, yeah. So you were thinking something like to this effect. And then so for example, when we go ahead and we want to create a cake, so I'm going to create a interface I cake and a public I cake create. And what I'm going to do is I'm going to validate that it has some specific materials in it before I let it go forward, and then I will go ahead and instantiate the cake. So I could say class sugar, for example, implements I cake material. And now I can say bool has sugar, var has sugar equals false, for each var material in material, if material is sugar, then has sugar equals true. If we do not have sugar, then we can throw a new invalid operation exception. Otherwise, we can return a new instantiated cake. And the instantiated cake, I'm just going to have take in a list of I cake material. And then I'm going to set it to a private list. Actually, it doesn't. I'm going to have the cake take in an int awesomeness factor.
Available at any good supermarket.
And a string name. And then I'll say string name. And I can say awesomeness factor equals awesomeness factor, name equals name. And now what I can do is inside my iCake material, I'm going to say awesomeness factor delta and string name modification. And sugar
cool.
is going to modify our awesomeness by adding 10 to it. And the name modification is simply going to be return sugared.
Delta is a nickname for changed. Yeah, difference. So you have like delta time, which is the time difference, and so forth. See, now you people really understand how difficult it is for me to get Nelson to do a simple example.
Well, yeah, I needed to be able to show something though. Like, so what we have here is everything that implements iCake material must provide an awesomeness factor delta, a healthiness delta, and a name modification. So now I can go ahead and add something like class whiskey, and it's a cake material, and the name modification is going to be, I don't know, alcohol. Its awesomeness factor is going to be 100 or 1,000, how about? And its healthiness delta is going to be -10 again. So what I can do now is I can go ahead and build up these numbers. I can say healthiness equals 0, awesomeness equals 0, name equals empty string, and for every iteration of the loop I can say name plus equals space plus material dot, actually I'm going to do that the other way around. Healthiness and awesomeness. And then of course I need to take one more thing, healthiness factor. Was this close to what you were talking about, Gavin? Or did I completely miss the mark of your example?
I was just going for, I was thinking the iCake would be the definer of it having to have your basic cake ingredients of sugar, butter, and egg. And then, obviously that would be, you can't just have a cake. A cake has to be a type of cake, so then you would have a fruit cake and a... But like Sigvald says, this is
okay,
an equally cool example. I was just going for something to get you to have, off the top of your head, to put together a very simple interface and class-based system, because it's, again, to my mind, that once you get your head around the thought process, it's probably easier than getting your head around the thought process via the syntax.
Yeah. But, well, okay, so let me just go ahead and execute this program and see if anybody has any questions on it. And then, I don't know. Sorry I failed, but this was a fun little example, though.
Well, no, and again, it comes to this whole thing of trying to find examples that will clarify it for different people, and it is, people think about things in a different way. And when you're fundamentally discussing almost, well, they are conceptual questions. It's far more variable in how you understand it, how you find an understanding for it, than it is in just saying, here's the syntax for, this is what you must do in order for it to recognize a method. This is much more, well, how, there's many ways to do these things, and it's
Right.
as much a question of taste as anything else, really, but informed by sugary alcohol.
Yes, sugared alcohol.
That's not bad for you, considering how nice it tastes.
But, and the idea of what we just did was, at least what I was thinking Gavin was talking about earlier, and I guess I just misunderstood, but what we can do now is we can provide different implementations of different materials without altering the functionality of our cake machine. I wouldn't call this the decorator pattern. This is the
This is the factory.
it is. It's actually, it is a factory.
The non-abstract factory.
So then, for example, we could have, I don't know, something else. We could have
Fruit cake.
eggs. Or what?
Oh no, Karen, you're going in different directions.
So eggs have and maybe we can expand this to use even more different object-oriented features, because we're not restricted to simply passing in a static thing on any of these. Well, I am going to pass in a static thing for the name modification. But what we could do is we could have a constructor, and we can have int count, and then we can say healthiness delta equals count times 2, awesomeness delta equals count times -2, and so on. So we can actually provide different requirements for the specific implementations or the specific implementations of that particular interface. So now, for example, we can say machine add material new egg 3. And if we were to run this, our computation still is proper because we're using this abstraction of iCake material so that we can use many different implementations for many different classes instantiated at runtime, but not have to change the functionality of our method whatsoever.
And I know this doesn't directly relate to the state machine, but it's more fundamentally about how to think of interfaces and come up with what should be in an interface.
Right. And the process that went through, you have to ask yourself, okay, what attributes of every bit of material modify? And in this case, we have 3 of them. We have healthiness, awesomeness, and name modification. Now, this example could be even more it would make it more complicated, but it would also make it more flexible. What we could do, and I'm not going to follow through completely on this implementation, but we could have the iCake material having these this one property, and then we could have an awesomeness modifier that has an int awesomeness delta on it, and then we could have an interface healthiness modifier, which takes in an healthiness delta.
You're going to have to check for errors because you misspelt it earlier but got it right this time.
Whatever. I'm not going to complete this example, but the point is that now by using role-based interfaces, what we have is we can have our alcohol can change the name, but it can also change the awesomeness, but it might not necessarily change the healthiness. Okay. I hate that freaking focus bug. Or freaking focus bug.
Wolf said, is it right to say that commands do game logic and the states just show what's happening?
Yeah. Commands are basically the game logic of this system. And the whole idea... Here's the thing about object-oriented design and what's really great about it. Almost every good design, in fact, every good design I've ever seen, it's always about creating layers and creating abstractions. And when I say the word abstraction, I mean not necessarily an interface, but it usually is. And I don't necessarily mean something that would, people think of abstractions like, in the general sense of the word, like C# is an abstraction over the CPU. I'm not really talking about that. When I say the word abstraction in this context, I'm saying that we are creating a language for our program, and we're giving our program different points of extensibility. And while we develop our program, when we want to add functionality, we have to decide which layer of extensibility that we want to latch onto. So, for example, if we wanted to add a new thing that the player can do, we would latch onto the commands extensibility layer. If we wanted to provide a different screen for the user to actually view, we would latch onto the screen's extensibility point. Now, if we wanted to provide some really, really important game logic that isn't appropriate to place in the commands, then we would put it in our other classes, like our player class or our basic room class, for example. That's where some additional game logic can go. But the point is that we have this program has 3 layers to it. It has your commands, which perform the intent of a user. The user specifies they intend to do something, and the commands actually carry out that intent. We have the screens or the states that provide a user interface to the user so that they can interact with our system. And then we have these different classes that kind of just hang out here on the side, which represents what would typically be called your data model, or the objects that exist, the actual representation of your world in the form of code. So, for example, a level is a part of the data model, as is a player, because a player has to keep track of how much health he has and his current inventory and his current room. So that's what the player has to keep track of. As a result, it's in this class. Now, different commands will affect this class. So, for example, the pickup item command will affect the player class, as will a drop item command will affect the player class. But being able to identify the different layers of your application and knowing where to place what code is so important to design, and that is the number one thing that good design lends you. Everybody says, oh, good design makes your code more extensible, maintainable, and reusable. And I remember reading all that stuff, in programming books when I was starting to do object-oriented design, and it always frustrated me because it was like, well, how do they make your code reusable or readable or extensible? And this is how. Because good design will make you create concepts in your program that only apply to your program. But once you understand the language of these concepts, then navigating the code becomes so much easier. Because let's say we want to look at the code that happens when the user picks up an item. Well, where do we go? Into our commands, and hey, look, there's a pickup item command. This is the code that's executed when a player picks up an item. Or at least the start of it. He delegates off to a few other objects, but we can clearly see which objects he's delegating to, so we can locate the appropriate code very easily. What if we wanted to know, how is it that a player can pick up an item? Where's the command parser that deals with that? Well, we know that's in a screen because it has to do with user input. And then we know it's going to be in a room screen because that's where the user executes the pickup command. So now if we just glance through this file, you'll notice, hey, here's the bit of code that actually handles interpreting the user's pickup command. So it becomes very easy to find things. This program could be 1,000,000 lines long, and if it still followed this same pattern, finding code would be just as easy as it was as I just described. I know I just did like a huge like thing. Sorry for the
have a chunk of my brain content.
And this is called model controller something, right? No, this is not MVC or model view controller. This architectural design pattern doesn't actually have a name that I know of. It's just a command system thing. It's a state pattern with a command pattern. That's all it is.
We will call it Gerald.
Yeah. When you say language, is this what's meant by the term DSL? Not specific, not really. A DSL or a domain-specific language isn't what I'm referring to here. Although I am in a very when I say the word language, I intend to say the word language because it's a method of expression, and it's a method of expression that has rules. The rules you come up with as the programmer, as the designer. You make up the rules. You make up the syntax of your language, and then you express your logic with your language. A DSL, however, is a very specific thing. A DSL is a language like SQL or regular expressions. Those are all DSLs. So a DSL, this isn't a domain-specific language, but it is what I would call a language. Yeah, it's about translating the domain into a language. It's about creating a language within your program and making it read well. For example, drop item command. Everybody read this command out with me. Engine, player, inventory, remove item, item. What's item? Item was passed into the constructor. Room, add item, item. What's room? Room was passed into the constructor. You can't express this code any easier than this. What's engine? Engine is the object that I use for my state machine. So as you see, it has the player object on it, the level object on it, the current screen on it, and the switch screen. Yeah, switch screen command is very simple. It's basically what we had before. All it does is informs the engine to switch the screen to whatever was passed in. Just a simple, stupid class. That the only reason I have this class is to remain consistent with the other commands. I mean, I could just say engine.switchScreen right in the command processor, but I really wanted to... I didn't want to break the convention that I had established with the command pattern.
Yeah, like Segwald said, it's important that a method signature should tell you what the method does and how to use it. You should be able to gather from, if it's got a return, what the return is, and what you're passing into it. And exactly, that's what made me think, funnily enough, of the cake example. You pass in the ingredients and you get back a cake. And depending on what ingredients you pass in, you get a different sort of cake.
So, I mean, that's all this is. And if this wasn't organized like this, what will we have? Well, we would have a class that is... well, this is a bad example, just because right now we have this is a very anemic game. It doesn't really do all that much.
There's no game in it.
Yeah. But the point is that if this were a single class with a huge switch statement, there would be no navigating that. And you would have a billion local variables, a billion fields, a bunch of static things, and there just would be no navigating. There would be no order. You wouldn't be able to look at your Solution Explorer and say, hey, I haven't seen this project before, but I do know the command pattern, and I do know the state pattern, even though I called it screens here for some reason. If I'm looking for this bit of functionality, because I already know what these patterns are, I'm going to take a wild, and these classes are named like they are, I'm going to take a wild guess as far as where the functionality is. And they'll most likely be right if I've done my job well.
Plus it saves on writing comments. You can just name everything properly. Well, it should be possible to read code as if it were comments.
Well, imagine this was just one huge class, and room.removeItem and inventory.addItem. Right now, these methods are really simple. They don't do a whole lot, because there's not much to do. But presumably, a feature that you would want to support at some point would be to execute some code given a specific item has been removed or added. So imagine how...
the gameplay.
You what?
I said it might help the gameplay a little, yes.
Right, and so you can imagine this code just getting bigger and bigger and bigger if it wasn't separated out into two objects. And now imagine that it wasn't even separated out into commands. Now you have your code getting bigger and bigger and bigger in the midst of every other bit of code in your program. Segfault, I haven't had time to read through this yet, but I really wanted to. So who was confused before going to or entering this class today, or fairly confused about what we've been talking about last week and is less confused now?
Hurrah!
Tell us how to show the folders on our console on a selected folder, but do you know how to show the files in a given folder? Yeah. All you got to do is you got to
have faith.
Yes.
And use directories.enumerate.
Lord Smooze. Oh man, Gavin, you have to watch Friendship is Witchcraft.
Not gonna happen.
Oh, it's so funny. It's so funny. It's just, yeah. You should also show the folders in our But how do we just show the files of a given folder? That's going to be file dot, or file, then of course import system.io dot, actually what am I doing? It's directory dot get files, derp. Ah. There's your code.
You got that? He's ready to go now.
Well,
Now, when would you choose to use the enumerate versions rather than the get versions of all these sort of methods?
let's see what this does. Enumerate, we can use the search pattern and the search option. And the search option, if I'm not mistaken, is what allows us to, it allows us to recursively search for files.
Which is irritating given that you have to enter a search term to get at that parameter.
Yeah. It is, but still,
frankly.
Generally speaking, I only need just the files in a particular folder, so I'll use directory.get files most often. Then I'll use enumerate files if I need to go deeper.
I don't think link just happened. Ooh.
Huh?
Misery said, did link just happen?
What about link?
Misery said, did link just happen? And it's
No.
not showing up. Oh, you haven't got resharper in. I was just looking at that going, oh well, system.link's not grayed out.
I actually set up my resharper never to gray it out.
Oh yeah, yes you did.
Because it irritates me when it grays it out, and because I use it more than any other namespace in the .NET framework.
Actually, link is a prime example of what I was saying about naming stuff right and not having to comment it. You can literally read link out. It's great.
Yeah. I use it more than system collections generic. Well,
You use it at the same time.
generally speaking. I mean, system...
You can link on something that you're going to.
But you don't need
generic
system collections generic
No.
to use link if you're using implicit typing. Because link's always going to return an IEnumerable of T.
Oh yes, bubble sort for the C++ people. Werner, good for sticking with us through all the C#.
Yeah, we can look at that. Great, now I have to switch modes into C++ land.
Well, I think you should whiteboard out bubble search first.
Oh, SCLR. I don't want stupid C++.
Did you hear me?
Yes.
Can you respond at least?
No.
I have no way of knowing whether you've actually taken in that I've said anything.
I'm just going to start this project and then think about what I would whiteboard. I kind of don't want to do it because of the last time I did this in class. I did something completely right, and I knew it was right, but then I started looking at it, and you know how like when you look at words long enough, they start looking funny? Well, I thought the solution that I come up with for a very simple problem was wrong. And I sat there staring at it, reworking the code, and Jason didn't say anything, even though he knew it was right the entire time.
I remember that.
Oh man, that was so bad. That was so bad. Alright, well I'm going to fire up Photoshop and talk about what bubble sort is. If you don't need me, I mean, I can if you want me to, but I would really rather not actually write the code out for a bubble sort for the C++ guys, but I'm more than happy to go over the algorithm itself, if that makes sense.
It's just tricky because obviously with all the homeworks for the C++ following on from the previous ones, fundamentally, if people haven't understood this, then it's going to be wrong in all of them. The two big things, well, the biggest thing that came up, I think, was also the parallel editing of the loops as part of the sort. That was an appalling sentence. Do you know what I mean? The parallel editing of the parallel sorting of multiple lists, arrays rather.
Yeah. Actually, why do I have... I don't want shape dynamics. Why is it feeling like it has shape dynamics? Am I just not interpreting what I'm looking at properly? Oh, my flow. That's why. Yeah, there we go. Much nicer. Okay.
Atomizer 74 says, wasn't bubble sort part of last week's homework, not this week's, which is already overdue. This week's homework was... Seeing this week and last week is very confusing in this class with the C++. But it was part of homework that has been due. But equally, the most recent homework was also a continuation of the same program. This was what I was getting at. So if it's wrong in 1 week, it's still going to be wrong in future weeks, which is why I'm getting him to go through it now.
Yeah, basically I still write at a slant for some reason. Yeah, whatever. Okay, so bubble sort. Bubble sort's a really interesting algorithm because it's generally given... Oh, Segfeld, never thought about that. Given a person who's new to programming only knows for loops and arrays, if you give that person, who may not have much or any real programming experience, enough time to sort something programmatically, they will eventually come out with a bubble sort. Because it's the most intuitive thing. It's a bubble sort is how you would sort something in the real life if you lacked intuition. Meaning, as humans, we can look at a big jumbled mess of things and sort of kind of intuitively gauge where they should be ordered. But if you lacked intuition altogether and had to go through a repeatable process in order to sort something, you would result in bubble sort. So, for example,
well, it's what you would come up with if you had to tell someone else how to do it blindfold. If you see what I mean, it's the list of instructions you'd give them, because you're not going to be able to tell them to do move card 5 into slot 3 and then move slot 4 into it's just going to confuse things. You've got to tell them, do this, then do this, then do this, and that's how bubble sort goes about it.
Wolf does ask, when you say allow the user to choose a file, give it a list of files to choose from, do you mean after they've saved some files, or do you want to start out with files already ready for you to load? The ones that you've already saved would show up, or ones that you placed in. Okay, so how would we sort this? In a very simple way. So we have 2, 5, 10, that looks like 16. Wow, I can't...
I was going to say, we'd just print it out, surely. They're in sorted order.
Oh, were they? Oh.
Well, I thought it was a 16, so in which case, yeah, they were in sorted order. You could CSV them.
Okay, so if we wanted to sort this from smallest to largest, the way that we would do it algorithmically is we would start by looking at a number. We would loop through each one of these items. So the first thing we would do is we would look at 2. What we would do What we
Hey, I put it in there rather than saying it on the video. I'll say it on the video now. If you use commas, it would allow for your appalling handwriting. Is that better, or shall I stick to typing it in future? Carry on.
Okay, so we would start by looking at a number. And what we would do is we would determine if this number is larger or smaller than the number next to it. And that would identify to us if we need to continuously, or if we need to swap those two. So do we need to swap 2 and 100? And the answer is going to be no. So 2 and 100 stay the same, in the same position.
And even there, that's too plain English for a computer. Because we're still implicitly, because we're saying, do we need to swap 2 and 100?
Right, we would say if 2 is x and 100 is y, then we would say if x is greater than...
Less than. Great, yes.
Y.
Good God.
So,
No. If x is less...
If 2 is greater than 100...
Sorry, oh, Jesus. I'm doing what you were just talking about. Carry on. I'll shut up.
So is 2 greater than 100? And the answer is no. As a result, we do not swap those two. And wow, I just totally made that illegible. Or more illegible than it already was. Okay, so the next thing we're going to do is we're going to look at the next number. Is 100 greater than 5? And the answer is yes. So we'll swap them. And when we swap them, we get a new sequence. And the new sequence is going to be 2, 5, 100, 10, 16, 23. So now we're going to advance our pointer once more and say, is 100 greater than 10? And the answer is going to be yes. So we get another sequence. We swap the two. We go with 2, 5, 10, 100, 16, 23. Now we look at the next number. The next number, again, is going to be 100, and we're going to compare it to 16. Is 100 greater than 16? The answer is yes. So we get another sequence. We get 2, 5, 10, 16, 100, 23. Now again, we look at this number, which is 100. We compare it with the number next to it, which in this case is 23. And because 100 is greater than 23, we swap them. So we get 2, 5, 10, 16, 23, 100. And I seriously think there's something wrong with my random example generator, but that's the only number.
It is, because you've ended up doing it once. Yeah. Well, I'll tell you what, turn the 10 into 30. Turn each of the 10s into 30, and that won't affect what you've done so far.
Okay. So... Okay, so now we're at the end, because once we get to the last number and there's nothing to compare it with, then we terminate. And what we do now is we jump all the way back to comparing the first number again. So is 2 greater than 5? No. Is 5 greater than 30? No. Is 30 greater than 16? Yes. So we swap them and enter in a different sequence. Then we get 2, 5, 16, 30, 23, 100. Now our pointer is on 30. Because remember, we started at 2, then we went to 5, then we went to 30. And now our pointer is back on to 30. So at this point, we now ask ourselves, is 30 greater than 23? The answer is yes. So then the resulting sequence, after we do the swap, is going to be 2, 5, 16, 23, 30, 100. And we get a properly sorted sequence. And the reason we know that this is properly sorted is that we can go through the entire list without having to do a single swap operation. So if we start at 2, is 2 greater than 5? No. Now let's go to 5. Is 5 greater than 16? No. Now go to 16. Is 16 greater than 23? No. Now go to 23. Is 23 greater than 30? No. Now go to 30. Is 30 greater than 100? No. And because we've gone the whole length of the sequence without doing a single swap, we know we are properly sorted.
And that immediately points up one of the reasons why this is commonly known to be an appallingly bad way of sorting things.
Mm-hmm.
Because in order to validate that you've finished off, you have to go through an entirely, deliberately ineffectual iteration right the way through however many things you're comparing. And remember, you could be comparing, words in a dictionary for alphabetical order, and you're looking at hundreds of thousands of words.
Well, the computer probably still could do that pretty fast, but if you're looking at like millions or tens of millions or billions, then you start to get boggishly slow.
And again, it depends on how out of order the list is, but
True.
you can't assume the best case.
The best case is
the worst case.
The best case is linear. The best case is that it's already sorted it. Meaning you only have to do an iteration over every item.
But that does really point it up. You still have to go through every single
True.
item in the list at least once. And that's if it is already optimized. Already sorted. But does that clarify for probably one C++ person who's left about what bubble sorting is? And really, because of the nature of what it does and the way it goes about it, it should be relatively self-explanatory to turn that into code, into code.
Right. The steps are already, even in English, in a very imperative language. If this, do that. Then loop here. Then if this, do that, and so on.
I'm not actually personally hating on bubble sort. I'm stating fact. It's an incredibly efficient way of doing it.
All right, sweet. Well, that whiteboarding wasn't a complete disaster.
No, it was very good.
Although I don't get the slant. I really don't. It's like, why? Why?
Because your arm isn't... You can't move your arm horizontally across in front of your body. If you hold your forearm out in front of you, you can't keep it at a right angle to your body and move it horizontally across without causing yourself quite a lot of pain around the shoulder and the back of your rib cage. Naturally, your hand rotates as you move it across.
It's frustrating.
Sorry, was that question supposed to be rhetorical?
Well, no, I'm actually, well, kind of, but also not. Like, how do I prevent it? It's just obnoxious.
Rotate the tablet slightly. Any more questions? We seem to be wandering slightly off topic. No, somebody's... You can always text your questions. Have you got a completely ill-informed opinion about recent news events in your area? Why not let us know about it, and then everyone can be completely bamboozled by your lack of consideration. Sorry, enough on one there.
All right, I'm going to go ahead and pause and step outside. I'll be right back. And I am resumed. Question: would you make try parse into a method or a class? And would you make it a lot of different overloads for it? I mean, sometimes you need to add other things like min and max or anything less after the and. I'm not entirely sure about the question. Are you referring to the int try parse method? I wouldn't wrap this method in anything that isn't specific to your program. And what I mean by that is, let me get my tablet out of the way. This isn't visual programming.
This must be invisible programming.
Yes, this is invisible programming.
Or auditory programming.
Yeah. Oh god, that would be int dot try parse open parenthesis. Oh man, that would be
parenthesis. That would fail.
I wouldn't wrap this into anything that isn't domain specific to your program. And what I mean is, I would do something like this.
You know what? I've written that same method about 5 times in the last 2 weeks just because it's quicker to write it out again than it is to go searching through projects to copy and paste it. I'm getting really intimate with various different... The word prompt has appeared a lot.
So I do something like that. If I needed any larger amount of abstraction, I would write another method. I would say, for example, int get int string prompt int min int max while true var res equals get int prompt if res is greater than or equal to min and res is smaller or equal to max, return res. So I would kind of like abstract them higher and higher depending on your purposes. So I guess an overload would be appropriate in this case.
Or things like, because I've been doing versions of, I've got a get unsafe user string, and then I've got a get validated file name and things like that just, it takes in the prompt and it takes in the relevant things it needs to know. But again, it all comes down to just keeping it central to what it's doing without it turning into a class, essentially.
Right. But to make less code, should we not just make one method instead of doing try parse everywhere? So what class would you put that in? I would put this into a static class like user input class or something like that.
Well, this does actually, perhaps you could just give a quick going over of this, but say you had a class that had all these different helper methods that you've made. How would you go about dealing with that in such a way that you could then use it in another solution?
I'll put it in its own assembly.
Basic. Yeah, but I mean, people, just as a bonus for people, because I've found myself with a collection of quite a few methods and things like this that I would like to have in other things.
Yeah, I do that quite typically. Generally, every project that I do, I create a base project. And then inside the base project, which is a class library, I put code into it. So, for example, I might have console in.
There,
You what?
He chose class library as the type there, by the way.
However, be very cautious about this. I would put this into a... Be very cautious about this, basically. Because the more that you use this code, the more difficult it'll be to create variations on it. And once you create a bunch of variations on it, then you start to get into bloat, where you have so many of these methods. So it's really a slippery slope, and it's something that I would just recommend doing what feels right to you at first, and you'll develop your own smells, your own instincts as far as how it's appropriate.
What I meant was, now what do I do in order to use it in another? I'm not actually talking about what goes in it. I'm talking about how to make a DLL and how to import a DLL. And
generally, what I do is I have a base project, and then I literally copy the code files from other base projects piecemeal into the project-specific base project that I have. And then once you have it in your base project, you can reference it from all your other projects by right-clicking references, hitting add reference, and double-clicking on your project. I wouldn't turn this into a DLL that I reused everywhere, basically is what I'm saying. Although I would create this in its own class library, I still would copy and paste the files piecemeal over. Just to appease segfault.
Shouldn't that be an public? Actually, something that Stu's lesson mentioned that I think is a brilliant idea for those sorts of things, though, is he said make it a snippet.
Yeah.
That would be really handy, because then when you suddenly go, oh, I need a get in that I need it to do it for floats, you've got the best of both worlds. You can have it there as a snippet, but you can then just bring in with a couple of button clicks, but then tweak around to your heart's desire to get to do what you actually need. In fact, did I mention to you, I mentioned it to someone, I thought it would be a good idea to do that for the design patterns. Make a series of code snippets, each of the design patterns in generic form.
Yeah.
So that if you go, oh, I need some observers, bang. Snippet, code, Wolf 90 said, snippet? Snippet? Probably not in that tone of voice, but could you just explain about a code snippet, show 'em prop or something?
Well, yeah, code snippet is just like that.
What was that?
I typed in the word prop and hit tab twice.
Wow, you're really not into explaining what you're doing today, are you?
Well, no, I typed in the word
Basically, a code snippet is it's basically a chunk of code pre-set up to act in a certain way. And in this case, by typing prop, and it gives you a kind of template with which to make a property.
Right.
And you can see from the highlighting, you can enter those two things that are highlighted there.
And there's a variety of these. But anyway, segfault, just to make you happier, here is the enterprisey implementation of our get input, where I could say our inputter equals new int 32 input, then I can pass in a new composite validator, then I can pass in a new min validator of 3 and a new max validator of 10. And now we can say var res equals inputter dot getInt. So now...
Yeah, that's so much clearer.
Well, I mean, I don't see any questions. Yes. But to make less code inline lines, you should make one method instead of doing try parse everywhere. So what class would you put that in? Or what? I would make it its own class, and I would make it like a console input class and make it static. That's it. But then just to appease segfault, I wrote an implementation that doesn't require static and allows me to composite different things. Why can't I use system.enum as a generic constraint?
Are there any more questions actually related to the classes before we get too much into esoteric coding things? I'm not in any way complaining about getting into esoteric coding things, but I think we ought to just, if anyone's desperate to know something specifically course related.
But NATO, did you find this useful? I mean, are you more comfortable with the homework now? Do you have a direction to go with the homework? And it's okay if you don't, because that's why we're here, to help out with that sort of thing.
You keep beating me around the head with it until it does.
Okay, so I guess no more questions. Segfault, you cannot use system.enum as a generic constraint. I'm not sure why. This doesn't make sense to me. It feels like you should be able to do... it feels like you should be able to do it, but you can't. However, I do want to point out that you can do this in IL. Sweet. Thanks, Wolf. I know this stuff is complex. It is, but it's also the next level of programming.
Yeah, just whatever you do, don't get into your head. Oh, I'm never going to be able to. I can't understand this. I'm never. This is a step up in complexity from 101.
Think about it this way.
But it's the only really big step that you need to make. For the rest of the course will be a breeze if once you get, and it will also probably fix this in your head much more because you're doing very similar sort of. The whole interface and class thing will come up again and again and again in different forms. I mean, as you saw from Nelson's Solution Explorer briefly, there are about 8 or 9 interfaces to deal with. So,
and think about it this way: there's really 2 types of coding that we've been talking about. 101 was all about what goes inside of methods. With the tools given to you by 101, you have the tools required to write most any program you can think of. But what we're going over in 102 is not what goes inside of the methods, but to how to organize what goes inside of the methods so that creating complex programs is a possibility instead of something that will lead you to, go insane.
101 was much more about syntax.
Mm-hmm.
This is because after that point, really, you will look up syntax for things all the time. It's just everyone does it. Nelson does it in the middle of. If somebody asks a question about something he doesn't know, he goes and looks it up. It's just part and parcel of doing it, because there is, partly there is just so much that's been done before, and you don't, and particularly, if this was an actual production situation, you haven't got time to reinvent the wheel, let alone inclination. You need to get it done. And again, this is where these patterns come in for design, because they are the best combined thinking of the last however many, probably 50, 60 years, going back to the to the pre-programming thought on this, but it's still part of the same thing. It's the way people have come up with. It's like the point at which people went, "Hey, these square wheels really don't work very well. There's got to be a better way."
Yeah, and it's funny to know that object-oriented programming really wasn't accepted until the 90s, like widely. even in early 2000s, I mean, people still struggled away from it. But about late 80s, early 90s is when things really start getting accepted as far as object-oriented programming. I hate to say it, but Java was really the first. Well, not really. There's small talk, I guess you could say. But Java was the first really widely used object-oriented programming language that had similar facilities to C Sharp. Of course, C++ had object orientation, but not to the extent or not to the level of in your face, you must do it this way as Java or C Sharp.
I know I was going to ask Chris this before, but I don't know if I ever did, which is, did you have to cover any of this with your architecture degree? Because I know it's based in thinking that came out of architecture. And pattern books, yeah. Well, the whole, I mean, I suppose the basic example would be things like the Greek column system, and Doric and Ionic and thingamajiggy. I'm just purely for, as far as I'm concerned, class is basically over now, isn't it?
Yeah, I'm probably just going to go hang up the recording and then answer
That's probably a good idea.
faults. So, yeah, goodbye everyone who is watching this in the future. Yeah, see you later.